happy Tuesday. Forgot what day it was. So today we are doing a short video combining like terms. Like I said in the email I sent y'all this morning, I think it'll be good. Y'all did cover the standard sum last year, so hopefully it's review, but if not, I will teach it like normal, and hopefully we'll be good to go. Alright, so this should be on page 71 in your math notebook, and we are going to go ahead and start. Alright, so some important vocabulary we want to talk about is like terms. Like terms are things that look alike in these expressions. They are terms that have the same variable and are raised to the same power. So yesterday y'all should have watched the introduction to algebra notes, and you learned that terms are separated by addition and subtraction signs. So these are terms that have the same variables and they're raised to that same power. Alright, so yesterday you should have learned coefficient. Coefficient is that numerical factor of a term that contains a variable. So coefficients are those numbers that are in front of those variables, okay? And that is what we call coefficients. So that's just some important vocabulary that we're going to be starting to talk about. Hopefully, like I said, you watched those notes yesterday, so you are aware of what constants are, coefficients, variables, terms, just those differences. And then also, hopefully, you remember that difference between an equation and expression. So remember, equations contain those equal signs, and expressions are just math sentences that don't state if things are equal. Alright, so how do we combine like terms? So we need to go through some just some information so we know how to combine these like terms. So a variable with no coefficient has a coefficient of. Alright, so if we have a variable and there's no number in front of it, which is that coefficient, we just assume it has a coefficient of 1. Okay, that's just an assumption we make. Alright, so terms take the operation symbol. The operation symbol directly to the left of the coefficient, okay? So your operation symbols are always going to be your addition or your subtraction. So if you want to make a note of that, addition or subtraction. My pen's not working. There we go. Because remember, you were taught yesterday that your terms are separated by that addition and that subtraction sign, okay? So your coefficients and the terms will take the operation directly to the left. All right, and then constants. So your constants are also like terms. Remember, constants are your numbers that are by themselves. There's nothing with it, okay? It's kind of alone. So that is just some important information that we need to know. For the next part, let me get a little highlighter going. Or we'll just leave it on pen. So it wants us to highlight the terms in the same color. Instead of highlighting, I'm going to draw shapes because that's going to help us more when we go to combine like terms. So we want to look at this and we want to see what looks alike, right? We're going to start with our 5x. So remember, like terms are things with the same variable and the same power raised, all right? And we just finished that real number system unit, so you learned that exponents are powers. So what else looks like this 5x, all right? This 2x does, and then nothing else, all right? We're moving on. Remember, it also said constants are like terms, so we want to see what is like that 20. All right, and we're going to circle it. Hopefully we're aware that 9 is the other constant. And then we want to look at this one. We have 3x squared. We're going to put a triangle over this. What else is like that x squared? In this case, just the x squared is like it. And then to simplify an expression, when you start to combine those like terms, you're going to add or subtract. So you're going to add or subtract the coefficients of the terms. So that's something very important to remember, that when we combine these like terms, we're just looking at those coefficients, okay? We want to make sure the variables line up, but when we add or subtract, we are just looking at coefficients. All right, so looking at number 1, first we want to identify all our like terms. So I'm going to circle everything that looks alike. So in this case, all these y's look alike. And then this x, I'm going to put a box around it. It's by itself. It doesn't have anything like it. So to combine these like terms, remember we take that operation to the left. So this has to add, that one has addition, and this one has addition. But remember, when we simplify an expression, we add or subtract the coefficients of the like terms. All right, so in this one, we don't have a coefficient, so we assume that it is 1. So we're really doing 1y plus 1y plus 1y plus 1y plus x. Alright, and you don't have to write that, that's just so we can see that we're adding those coefficients. So we're really just adding the coefficients. So 1 plus 1 plus 1 plus 1 would give us 4. We have to then attach that variable, which is a y. And then does anything add with that x? There's nothing like it, so we just bring it down. So our simplified expression for this first one would be 4y plus x. Alright, so that was our first example. Hopefully it might be coming back to you, or you're at least like, hey, this kind of looks familiar. Or if this is new, hopefully we're getting the hang of it. Alright, so let's go ahead and look at number 2. First, we want to identify those like terms. Alright, so first is a 3x. I want to see what else is like that 3x. We have a minus x. And then we want to see what is like those y's. So we have 2y and we have 7y. Alright, so now, to simplify those expressions, we just add or subtract the coefficients. So we have 3x and we have x. But we take this operation sign to the left. So this is really saying 3x minus x. And remember, if we don't see a coefficient, we assume it's 1. So that's really saying 3 minus 1, which is 2, and we attach that variable. For the next one, we have 2y, and then we're adding a 7y to it. Those terms are alike, so we add those coefficients because the operation beside it is addition. So 2 plus 7 would give us that 9y. So we simplified it, and we're good to go. And that would be our answer. All right, moving on to the next one. What's different about this one? What do we notice? We notice that we have an exponent in these, all right? So what terms are alike? Are all of these x's are alike, or the x's with just those powers alike? So first, is there anything like this 5? No. So we're gonna go ahead and bring this 5 down because we know there's nothing like it, and we can go ahead and drop that down. All right, next, we have 8x squared, 2x squared, and then a 3x. So we want to combine the terms that have the same variables and same powers. So in this case, the 8x squared and 2x squared are the same. All right, we look to the operations to the left. We have a positive 8x squared plus a 2x squared. That would give us a 10x squared, and it's positive. And then, sadly, there's nothing like this 3x, so we just minus 3x because we have to remember to keep that operation sign. So our simplified expression would be 5 plus 10x squared minus 3x. All right, and then, I know I'm moving fast, I'm sorry, but then the last one, first we want to identify our like terms. So we're going to start with that 2z. What else is like that 2z? This z. Is there anything like this 4x? Nope, and there's nothing like the 9. So we're really just 2z plus a z, so that would give us that 3z. Because remember that coefficient has a 1 even though we don't see it. And then plus 4x because there's nothing that we can combine to it. And then plus 9. And then this would be our simplified expression. Alright, again, went super fast, but I think y'all are good. I think you'll be good to go with combining like terms, not vocab. These 8 you will do on your own on the following page. Remember, of course, same thing goes. If y'all have questions, reach out to me. I will be available on the Teams. You can call me anytime today after 2 o'clock. All right, good luck, you guys. You got this.